Having examined the production and allocation of biomass, we'll now look at patterns of the loss of biomass, tissue turnover. The balance between NPP and biomass loss determines the annual increment in plant biomass. Senescence causes tissue loss at times when maintenance costs greatly exceed resource gain. You might think that losing plant biomass, for that biomass to die and be shed, would be considered an entirely negative factor. But senescence is part of a strategy in many cases. Some species have leaves that really live a relatively short period of time. This is Ocotillo, which is found in the desert southwest of North America. And it produces leaves when there are flushes of rains. And it can produce 7 flushes of leaves a year. And these leaves will only last a couple weeks until it dries up, and then the leaves are shed. When it rains again, new leaves are produced, and then they are shed. This must seem pretty wasteful in some cases, but actually it's part of a plan to maximize resource capture and minimize losses. What senescence does is it enables plants to retain resources. And so in a case where you have an investment of resources into a unit of biomass, such as a leaf, that how long to retain that investment is not a simple question. And often what plants do is that they'll senesce that leaf, they'll lose that leaf or shed it before a period when the leaf would have been lost anyways. And senescing it on your own terms when you want to do it allows you to pull resources out of those leaves such that eventually when it's shed, you can maintain or retain some of the resources that were inside of there. Senescence also enables plants to shed parasites, pathogens, and also herbivores. And so if you have a unit of biomass that's out there for a long period of time, that pathogen load is going to build up. And by shedding it, you can prevent those pathogens from being transferred, potentially, to new leaves or infecting the rest of the plant. So senescence is a pattern by which plants will shed biomass for good reasons and for purposes that benefit the plant overall. Now, plant biomass is lost for other reasons that are often not necessarily under the control of the plant. Large, unpredictable biomass losses occur in most ecosystems. To be honest, almost all ecosystems have disturbances in one form or the other. So, for example, a lot of forests will have periodic fires. And when these fires occur, almost all the plants will be killed, and the next generation will start after that fire. While we consider the timing of these disturbances unpredictable, they're not necessarily unexpected. And there's a series of adaptations in plants that are associated with the reoccurrence of a particular disturbance.